Hello all, in this video we are just going to see a small program which will help you to understand about the term frequency, and the term frequency is actually calculated by using the frequency distributions function. And what a frequency distribution function does is that it records the number of the times, okay, it records the number of the times each outcome of an experiment has occurred. Okay, so a frequency distribution could be used to record the frequency of each word type, okay, in a document. And frequency distribution can be defined as a function mapping from each sample to the number of the times that occurred. So basically it helps you to identify the frequency of the terms in a record, right? So that's what. So but you have to think it as a probabilistic distribution, right? So when you look at the import, I mean, like all the packages to be imported, you need to have NLTK package, and you are actually importing this frequency distribution from NLTK.probability. Okay, so this is very important. And then comes you are actually including the stop words as well, and you are downloading all the stop words. So this all these things you already know, and you are actually setting all the stop words to stop underscore words, right? So this is what you have done. And then you are actually using the Gutenberg corpus here. So this is a corpus which has got almost like 2500 free electronic books. Okay, so this is what it has got. So this is actually throwing you error because you have not run the file in the order. Okay, because when it is actually running, it is actually showing you error because it cannot find the stop words, right? So now you are actually downloading the Gutenberg. So once you download the Gutenberg, and then you can also I mean, like, so this just shows you that the file IDs, I mean, like, which all are the different books which you have. So it just shows you the initial view, and then you are actually reading the Brian. So this one, so Brian stories.txt. So from this you are actually taking the words, right? So this is the storybook that you are actually taking, and then you are actually doing a little bit of pre-processing here. And after that you are actually coming back to the frequency distribution. So it records, as you know, it records the number of the times each outcome of the experiment has occurred. So this is exactly what we have actually learned. So say if you have cat, dog, fish, everything, then we can actually categorize them as cat, dog and fish, and the dog is 2 and the cat is 3 and the fish is 1. So this will be actually given to you, that's all. So here what you are basically doing is that you are actually finding the frequency distribution of the word. So this is how you will actually call this particular a function. And when you look at the length of the words in that particular whole thing, Brian stories, you could see that this much. Then you are actually making it as different sets, because here we need to make it as different sets. So you are making it as different sets, then you could see that almost 3688. And frequency distribution so works like a dictionary, right? So dictionary with the keys as the words in the text, and the values are nothing but the count. So it looks like a key value pair. So when you look at here, so you are actually traversing through the FDIST, and you are actually taking the first 10 words in that, and displaying both the word and its corresponding count. Okay, that is what actually you are doing. So when you look at it, you will get the word and the count. Say now if you want to find out the probability of it, then you can also do that by using this particular formula. So if you want to know the probability distribution itself, you can actually come out with the formula of this xv, and what is the v, it's your count divided by the length of the f distribution. So you will get the probability. So this is how it works. So this is how actually you could find out one of the ways for finding out the term frequency. So this term frequency also will help you in the feature extraction, or for identifying the major words or the topics from within your main content, right? And then comes the TF-IDF. So we'll see few examples for identifying the TF-IDF. So here we are actually importing the NLTK package, and after that we have just taken some lines of code from Bahrain 2030 Vision website. Okay, and so these are the codes which we are actually I mean, like, the text that we are actually going to work upon, and then we are going to clean a little bit. So cleaning we need definitely the regular expressions. By this time we already know, and the stop words we require, and we need a stemmer and a lematizer. And for that, for the stemmer we are taking the Potter stemmer, and for the lematizer we are actually taking WordNet lematizer. And then we are actually downloading the Punket. Punket is basically made to learn the parameters in the corpus, and that will be learned in an unsupervised way. So say such as list of abbreviations, acronyms, etc. So that's why we require that, and we have downloaded the stop words, and we know the WordNet as well. So WordNet is actually kind of a lexicon where it contains all the words and its associated words, and everything will be there, right? And we have actually downloaded the WordNet also, and then we have this Potter stemmer, and the pre-processing is basically done. So we are using a simple regular expression. So in this regular expression, basically it will match all those uppercase letters or lowercase letters, and it will also identify the, like A to Z means it will try to understand everything between A to Z, right? And it will negate all the following characters. And then we are actually doing the pre-processing of lowering the capitals into small letters, and then we are splitting the sentences, then we are applying the lemmatization, right? And then appending the space in between the results. So this is what actually we are aiming at for the pre-processing part. So exactly this is what we have actually done here. So we have actually taken the paragraph as the sentences, and this is our stemmer, and this is our lemmatizer, and this is the corpus is initially empty because this is where we are going to plan our sentences in the final result. And we will go through the length of each sentences, then we will do the we will apply the regular expressions, then the lower, the split, lemmatization, then we are actually joining the results with the, and then we are actually finally appending it to the corpus, which is initially empty, right? So it's very easy for you to understand. So if you are looking at the first sentence in your, or first one in your corpus, you will get this launch vision, so blah blah blah. It's just taken everything, and stop word is removed and everything, and this is the first one which you will get. So now when you have to calculate the TF-IDF, so the best way of calculating and understanding about the TF-IDF, I always feel that the Wikipedia definition is the best one for us to understand about the TF-IDF. So for understanding the TF-IDF, TF-IDF is nothing but TF into IDF. So we need to know how to calculate TF. We need to know how to calculate IDF. Then we need to have then you should multiply TF and IDF, right? Values. That's how it works. So when you look at the term frequency, as you all know that, how many times the frequency of the term T within the document. So its formula is as simple as its simple ratio. It's a simple probabilistic function. So TF-IDF of T is this your term, and upon the document, so you have the frequency of the T comma D divided by the sum of all the frequency of term. So this is how it is. So it's very simple for you to understand. And then you have to also understand about the inverse document frequency. So why we go for this inverse document frequency is that we need to give weightages for those rare terms which is across the documents. So it is logarithmically scaled inverse fraction of the documents that contain the word which is the rare word. So it's a measure of how much information the word provides. So understand that inverse document frequency will give you the amount of the it will help you to understand the kind of the information, specific information that each word is actually providing to you, which is spread across the document. So sometimes some of the words like the occurs many number of times. So when you take the inverse frequency, it's actually you're taking the logarithm of it, so you will get a lesser meaning. So that means that the doesn't provide much of information for you, right? But say just you have a rare word called called artificial intelligence in across the documents, but you will understand that artificial intelligence, that term actually brings you a lot of information than the word which is the, right? So this is why we basically go for this inverse document frequency. So in inverse document frequency, you are actually taking the logarithm of n divided by the document and T, which is element of D, right? So this is how actually you are doing. So it's an inverse document frequency. So this is how n is the total number of the documents, and this is the number of the documents which is containing the term T, right? So if the term is not in the corpus, right, so this will lead to a division by 0. So normally, so we will have this definition in such a way that log n divided by 1 plus, so that it is doesn't end up with something like division by 0 error, right. So this is nothing but inverse document frequency. Now the final formula is very easy. So we know how to calculate TF of TD and IDF of TD, then you have to simply multiply them, right. So the beauty of the in order for you to understand or to know the beauty of this definition, so a high weight in TF-IDF, say if you get a high weight in TF-IDF, okay, so that means that a high term frequency in the given document and a low document frequency of the term in the whole collection of documents, the weight hence tend to filter out the common terms. So it will actually filter out all the common terms because you have high frequency for the word, but you will get a lower value here, so it will balance it out, right. So since the ratio inside the IDF long function is also equal to 1 and the IDF is also equal to 1, your whole values will be will be within this 0 to 1. So there is a small example actually which is given again in the Wikipedia, which I always feel like is the one of the best examples. So there are two different sentences, which is actually two different documents in fact. So the documents has got the sentences like, this is a sample, this is another sample, and it's corresponding the term count. So the term frequency is also given. So if you want to find out the term frequency, it is very simple. So the term frequency, the formula is basically this is the formula. So the frequency of T over T divided by the sum, right, of all of them. So when you look at here, say if you want to find out this, okay, that TF-IDF for this, then what you have to do, so it's very simple. So always understand that when you find out the TF-IDF, the TF-IDF will be worked out for a particular term in a document, okay, upon a document. So this is how you will work out. So say you are working, you are finding for this, so it is actually 1 divided by 1 plus 1, 2 plus 2, 4 plus 1, 5. So this is the total number of counts. So 1 by 5, right. So again in this particular document, if you see 1 plus 1, 2 plus 2, 4 plus 3, 7. So the total is 7 and the count for this is basically 1, right. So 1 by 7. So you got this count, I mean like the term frequency count, and now you need to find out the IDF. So IDF is basically here. So when you look at the IDF, it is N is the total number of the documents, so it is 2 divided by this one. So T, the number of the documents were the term T, right. So when you look at here for the this IDF of this and D, it is like 2 and this occurs, right, number of the documents where this occurs. So there are two different documents, in both of the documents this occurs, so 2, right. So 2 divided by 2, so log of 2 divided by 2 is 0. So when you calculate this, what happens is that both of them imply it's to 0. So that means that the word is not very informative because it is not closer to 1, it is actually closer to 0, right. And again when you look at another maybe another example like example itself. So when you look at it, so 0 by 5, right, 0 by 5 is say the example is not available in the first document itself. So 0 by total count is 5, so 0 by 5 is 0, and here it is actually 3 by 7, right. So 3 by 7 you will get it. And then IDF is example. So what you could do is that you have two different documents. So N is capital N is the number of the documents. So 2 divided by this example appearing in how many documents, right? That's a denominator. So example is actually occurring in one of the documents. So 2 by 1, right? So in only one of the documents it occurs, right? So when you find out the TF-IDF of example upon D1, so upon D1 it is 0, but upon the second document it is basically it is giving you some particular value. So you are getting some value which is actually closer to I mean like it is 0.1. So it is actually somewhat it is relevant to. So when it comes to, so this is how you will understand that it is 0. So that means it is this example, the word example is not relevant to the first document itself, and this is the probability or this is the percentage that at which this particular word is actually relative to the second document. So this is how it will help you to identify the TF-IDF, right? So now coming back to the to how we can actually use this and apply this in the TF-IDF model. The first one is that we need to create a TF-IDF model. So for creating the TF-IDF model, we are basically using the sklearn package. So from the sklearn library, you are actually taking, so in sklearn you have this TF-IDF as vectorizer. Actually that is there in the feature extraction.txt. That means you have functions which are packages for feature extraction and explicitly for the text you have, and in that there is a function called TF-IDF vectorizer. So we are going to use that particular function. So CV is equal to TF-IDF vectorizer. So x is equal to cv dot fit transform of corpus. So I mean, like, we are going to apply this corpus upon this fit transform. So we need to know what is actually this fit transform. So it is used on the training data. So always understand the fit transform is used on the training data, so that we can scale the training data and also learn the scaling parameters, right? So hence the model built, okay. So hence the model built by us will learn the mean and the variance of the features of the training set, and the learned parameters are then used to scale out the data. So this kind of a, I mean, like, transformation means this kind of a normalization which we will do upon the data, and then you are actually making this output to be represented in the form of an array by using the toArray function, right? So if you look at the array and you are printing the x is nothing but the final results will be there in the x, right? So when you look at it, you could identify that, you know, you have got the terms, I mean, like, you have got certain values, right? So 0 dot and all this values. So this values basically will help you to identify that, say we are actually taking the corpus, right? So in the corpus you will understand that, so the first term, whatever be the first term, that term is basically, you know, relevant to your document, and this one is also relevant. I mean, like, you know, say this is not that relevant, so this value is not relevant, this value is not relevant. So like that you will be able to identify which of the terms are basically relevant to your document or not, right? So this is how you will actually you know, work on this, right? So another simple example, I wanted to say the same example which we have actually seen in the Wikipedia. This is what it is. So I'm just, you know, putting it as a document, I'm just putting it as a paragraph, and then applying all the pre-processing that we have done. So we have sample, another, all those the etc is actually gone, and another sample, and you are actually doing it. So when you look at it, so you have sample and you have another sample, right? So it just gives you, like, in the first document it is not having that much of so sample is there in the first document, so it just gives you, like, it is relevant, but in the another sample is you know, actually relevant in only this much relevant in this document. So that's all which you will be. Now if you want to give exactly like two different document A, document B, that is also possible. There is a function called bag of words where what you will do is that you can use a simple split function, and you will be splitting this whole document with the help of this you know, separation. So separation actually here is actually the space, and you are actually taking it as bag of words A and bag of words B, and we will learn about bag of words in the next coming sessions in detail. When you learn about the word embeddings, you will learn about bag of words and skip gram models in a detailed way, right? So you're actually making it as a set of bag of words A, and a set of, you know, I mean, like, you're categorizing it and you're putting it as unique words, and you are finding the number of the words. So it's just a number of the words, and you are actually getting the keys, and you are going through each and every one, and you are actually, you know, counting each words in the number of the words, right? For A and B you are actually counting, then you are actually using the stop words, and you are computing the. So here what you have done is that you have actually, you know, coming out with a function called compute TF, where you will pass the dictionary and the bag of the words, and here you will compute the whole. So this is your normal function which you have seen, but we have actually come out with the function itself, that's all. So you are basically doing the TF dictionary count is nothing but count divided by the float, right? I mean the values, and so you got the TFA and TFB, and then you are actually again, you know, coming out with a function for compute IDF. So compute IDF, you are using the IDF dictionary, so again you are actually computing the IDF first, right? So this is a function which will help you to return the IDF. So here basically when you look at it, it's your log of n divided by the number of the documents, right? So it's the same thing, but you have actually made it as a function, that's all. So you are actually passing it out and you are getting it. Now you are actually computing your TF-IDF. So in TF-IDF basically you are actually taking the value into, so here it's a value, right? The value into the TF-IDF words, right? So IDF word is what is actually returned. So that will actually give you a TF-IDF, right? So when you compute this, finally, when you compute this, you know, you will get the same thing. So this is this another sample is so this is actually, so for the document 1, how is it actually relevant? For the document 2, how is it actually relevant, right? So this is how you will actually get it. Now we were also talking about the TF-IDF vectorizer. So TF-IDF vectorizer will convert the values into vector format. Okay, so here actually you can, instead of the corpus, you can actually, this fit transform of corpus, we have already used it in the previous example, right? Instead of that, you can also give all the documents individually, that is also possible. and this function has changed from the like now it is actually giving get dot features names out. So this is the feature names, and then you are actually making it into a dense vector. So this is a vectorization step, and then actually you are making it into a list, and then you are actually putting it into a panda frame data. Okay, so when you look at it, the data frame will always work in the form of an array. So if you could see that, how each one is basically giving you and giving you about the how each element is actually relevant to each document, you will be able to identify from that. So the main idea behind the TF-IDF is that. So this shows that in the above example, so the word another doesn't appear in the document 1 at all, and it is totally irrelevant. So that's what actually it is here. So as the value is 0, right? So this is how you have to understand about TF-IDF. So hope you got an idea about what is TF-IDF, and this is the way they will extract the details from the documents. Okay, so let's see on another video. So if you have any doubts or anything like that, always get back to me. Thank you so much.